Okay guys, today we're going to be talking about the line of best fit. There are three ways to create a line of best fit. You can use paper and pencil, which is a flashback to the 8th grade. You can use a multi-view calculator, or you can use a graphing calculator. I'm going to show you all three of those ways. Keep in mind that a line of best fit may pass through some, none, or all of the points on a scatter plot. So here's the paper pencil example. The example is we're wanting to know, is there a relationship between the amount of hours spent studying and GPA? So the X values here represent hours per day spent studying. The Y values represent GPA. So I want you to take a minute. I want you to label your graph and plot your points. That's what I'm going to do. So go ahead and pause the video. I'm going to do that right now. I want you to pause the video. Okay, so at this point you should have labeled your y-axis, GPA, labeled your x-axis, hours per day spent studying, and then you needed to plot the points that are up here. Okay, so the next thing you want to do, if you're doing this paper pencil way, you want to identify 2 points from your table. The 2 points I found are 1 and 74, and then I also picked 3 and 91. So, do you remember the slope formula? That's going to be y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So your y2 minus y1 over x2 minus x1. So for the slope here, we're going to have 91 minus 74 divided by 3 minus 1. When you do that, you get 17 over 2. And so the decimal version is 8.5. And that's your slope. So the 2 points on this line that I chose were 1 and 74 and then 3 and 91. So I'm going to get my ruler and I'm just going to make sure that my line goes through those 2 points. Okay, that pen is not working very well. Okay, there we have it. So, based on that line that I just drew, what do you think that your y-intercept is going to be? It would appear to be between 60 and 70. So it looks like it's going to be at 0.65. So when you're writing your line of best fit, remember it's y equals mx plus b. We have our slope, we have our y-intercept, so we can write an equation for this line. Based on the two numbers I got for slope and y-intercept, our equation is going to be y equals 8.5x plus 65. That is using paper pencil to find the line of best fit. That's the first way. The second way is to use the multi-view calculator. Okay? So in your calculator, it's a little bit different. It's not mx plus b, it's y equals ax plus b. For whatever reason, the calculator assigned slope to the letter A. Not sure why, but that's what it is. So to do this, you get your calculator, like I have here, and you're going to enter this data. So the x values are going to be your L1, The Y values are going to be your L2. So you're going to hit the data key, delete whatever's there. And so for L1, we're going to put in these numbers 0, 0 0.5, 0 0.51, 1.52, 2, 4, 3, and 5. 0. Okay, you should have 10 numbers when you're done. The next list, you're going to scroll over and you're going to enter here starting with 54. 54, 61, 69, 74, 81, 86, 84, 94, 91, and 96. Make sure you have 10 numbers. Okay, so we've entered our lists. What you are then going to do is hit second data. And instead of option 1, like you're used to, you're going to hit option 2. Hit enter. You want to make sure that the X data is L1 and the Y data is L2. That looks right. So go down to calculate, hit enter. And then you're going to find this long list. You're going to keep going down till you get to D, E, and F. So your A is your slope, your B is your y-intercept, and then we're going to talk about R in just a minute. That is called your correlation coefficient. Okay. So for our equation, we use the A and the B in the calculator and just round to 2 decimal places. So y equals, it says A is 7.966, so we're going to round that. We're going to say that's not 7.97. Remember, there's an X attached to it, plus your y-intercept, and our y-intercept here is 63.47 if we round. Okay, and that's how to find the line of best fit using the TI-30 calculator. The next section, it says, what is the correlation coefficient? So what is our R value here? R equals 0.91. Basically, the closer that number is to 1, the stronger the correlation. So if that means it's got a strong positive correlation. If this were a negative 0.9, it would have a strong negative correlation. So what does that mean? What does that tell us between the relationship, about the relationship between hours per day spent studying and GPA? That tells us, because our correlation coefficient is close to 1, that there is a strong positive correlation between hours per day spent studying and GPA. Take a minute and write that out. Okay. And if you look at the bottom of this notes page, these are the directions that I just went over for how to find the line of best fit using your calculator. Okay. If you had a graphing calculator, these could be the directions you follow. But I've also made a video for Desmos. So that's going to be an additional video for today I want you to watch, because in that video, I go over this question. Okay. So take a minute, I want you to pause the video, I want you to try this question. Okay guys, so when you did this, if you use your calculator, this is the list that goes in L1. This is the list that goes in L2, and you just followed the directions for finding A and B in your calculator. When you do that, you should get this line of best fit. Y equals 13.57x plus 122.14, because that was the A you got and that was the B you should have gotten, either from Desmos or your calculator. And then the second question says, predict the temperature to the nearest degree when the setting, the gas mark, is 20. So you use this line of best fit, this equation that you got, and then you're going to plug in the number 20 for X. When you do that, you get 394 degrees Celsius. Again, there is a video of me using Desmos going over this question in more detail if you would like to see that. Okay, at the next part of the notes, it says, given the two scatter plots below, describe the type of function that would best fit the data. In Algebra 1, you learn about 3 different types of functions. You learn about linear functions, you learn about exponential functions, and you learn about quadratic functions. So, this function, this data, would be more like an exponential function. It's not linear here. It does not make a straight line. It's more like a curve. This data is going to be linear. And then the last question at the bottom of the page just says, which of the following would best fit the data and will create the best predictions? Well, which one of these fits the data best, meaning which one of these lines go through the most points? It looks like your first option, and this would be an example of exponential regression, and it best fits the data because it goes through most of those points. Okay, that's all for today.